All right, we got to talk about slope. Slope is like staircases. I think I mentioned this in that first lesson. So we look at these three staircases, and we say, which one is the steepest? Well, steepness is not just about the size of the numbers, strictly. Okay, so we can't say, well, 8 is bigger, therefore it's steeper. Okay, we have to look at both, and we have to look at not just like the flat platform of the step, but also how high it goes. So we're looking at both. Okay, that is what we call rise. And this is how it works. Rise over run. Okay, rise is the up and downness of the line. Up or downness. And then run is left or right. So it is a ratio of rise to run. So this first staircase, I can see it's up 5 to the right 5. That's a 5 to 5 ratio. So its mathematical slope or steepness would be 1. This next one, I can see it's up 3. So it's a 3 to the run is 8. It's a 3 to 8 ratio, 3/8 ratio, which has a decimal, 0.375, if you care. But I can see clearly that this ratio is smaller than this one, and so I know that this one is steeper at least between these two. But then we have this last one where I have a rise of 6, so that'd be 6 over run of 4. 6 over 4 would simplify, I'd just make it 1.5. You can say 3/2 if you want, but 1.5 is good. And now I can see that the one with the steepest staircase is staircase number 3. That seems like a small platform, so I'm not suggesting you build your stairs like this, but it's steep, all right? It's at least steeper than those other two. I prefer this one because I'm lazy like that. But it's all about rise to run. It's a rise to run ratio. And now when we look at these on graphs, of course, it would just be, you'd have lines in between here. And also, you're going to have endpoints on these, okay? So when you have endpoints, they're not actually going to show the staircases, but I'm going to draw them in so that we can see rise and run. Well, there's some, I just took these off the internet. Don't tell anyone I did. But these are staircases, right? And this one is going in, I think that's an actual, like this has not been skewed at all. That's a pretty steep staircase. But older homes have these kind of stairs that are very steep, very small platforms to step on. So if you have a house from like the 50s or 20s, you may see these types. Of course, this type looks pretty good, not just because it's, whoever built it made it pretty, but it's flatter for me, and I like that. I don't like this one. I'd feel like I was going to fall down. But again, if you looked at these, you could say which one is the steepest, and if you had at least the profile of it, you could possibly make that decision, okay? So when a linear relationship is graphed on a line, you call the constant rate of change of the line the slope, which we already seen from the last slide it's the steepness of the line, which is a ratio of rise to run. So slope on the graph, find the coordinates of 2 points on the graph, because that's all you need is 2 points on the graph. You need to make sure you can define them though, so they need to go through the corners of the grid. Otherwise you have fractional values, which we don't want. We do not want to work with fractional values, plus you'd be guessing. Find the rise, how far up does it go? Then find the run, how far to the right it goes. And remember, this is going to be on a grid, so if you have 2 points like this, you'd say how far up the street you'd have to drive, and then how far down this street you have to drive. Okay, rise and run. And then, yeah, it's a fraction of rise and run. So here's our graph that we got to find the slope of this blue line. But again, we need 2 ordered pairs that we can use, and there's 3 that we can choose from. I see this one. It's going exactly through that corner that'd be 0, -4. And then it's going through this corner at 1, 1. And then also this corner at 2, 6. We only need 2. Okay, so choose 2, any 2, doesn't matter which 2, and then go with that. I'm going to choose 2 that are at least close together, these 2. So I'm choosing 0, -4, and then 1, 1. But like I said, we want a ratio of rise to run. So I'm going to look for my rise, and I'm going to start with the rise. Some students choose to use the run first, and that's fine as long as you remember it goes in the denominator. It has to go in the denominator. If I didn't specify this before, if I ever go down, then then my rise is negative. If I go to the left, it makes my run negative. It's possible to have both negative. Me personally, I always go to the right, meaning I'm going to find the point to the left and then always go to the right, making my run positive. You don't have to, though. So my rise here, I can see that I'm going to have to go up to this street, and then I'm going to have to take a right on this street. See that? But how far up does it go? Well, starting from this point, don't include that point in your counting unless you're going to count 0. 0, 1, 2, 3, 4, 5. So I'm going up 5. That's my rise. It's up 5, which makes it positive. Not that you have to show the positive sign. And then I can see I'm going to take a right there. 1. Okay, so my run is to the right. 1. And that's a 5-to-1 ratio, which simplifies the 5. That's the one we really want, just the 5. So if you had by chance chosen this point at the very end here, you would have had up 10 to the right 2, but you'll see that that also simplifies just to 5. 10 divided by 2 is 5. So the nice thing about straight lines is that steepness does not change. You'll always have the same steepness, which means and that's why it doesn't matter which 2 points you choose. You can choose any 2 points.